Assalamu alaikum. Welcome to our research paper presentation. First of all, thank you for accepting our research paper in STA conference. I am MD Shourav Hossain, student of Computer Science and Information Technology Department in Port of Science and Technology University. Our research paper title is a breakpoint estimation using age-based SR model on COVID-19 epidemic in Bangladesh. Here is our presentation outline. Introduction: COVID-19 prediction and breakpoint estimation have granted significant attention for facilitating the recovery of normal and healthy life. The SR model is widely used for breakpoint estimation and prediction. In this paper, we propose a variant of SR model, specifically an age-based SR model to estimate the breakpoint of COVID-19 motivation. This pandemic has shown us how crucial it is to prevent an epidemic rather than the treating it casual at first and suffering the consequences later. It is not a brand new phenomenon on by the pandemic we are currently experiencing. Disease outbreak have occurred in the past and will continue to do so. That is our research objective: to improve the awareness and precaution of COVID-19 and to draw attention for contaminating difficulties on COVID-19 in different stages, to predict the breakpoint and the highest number of infection and find out the COVID-19 epidemic characteristic. Research significant: the result from the age-based SR model demonstrate a minimization of the gap between the predicted model and the actual data point. The finding indicate that middle-aged people are the most vulnerable group. Here we show the comparison of the proposed approach with some existing similar approach. There is the some different model and their key finding. SIR model capture the basic epidemic dynamic. SEIR model the incubation period, especially for disease with significant incubation period. SIRD model to analyze the facility and estimate the infection facility rate. Is structure SIR model consider the age-specific mixing pattern and effect. Modified age structure SIR model proposed a modified model to study the spread of COVID-19 and type of viruses. Age-based SIR model that we used or our study. Age-based SIR model used to estimate breakpoint and focus on the age-specific estimation. Problem statement: to use SR model for estimating the expected breakpoint to handle time series data. SR model considers the total population and the separation of the susceptible infection contact and into different ranges. Methodology: SIR model, susceptible, infected and recovered model. SIR model consists of three components. The susceptible defined by S, the number of susceptible individual; infected defined by I, the number of infected individual; and recovered but defined by R. These are people who have been exposed to the disease and have either recovered and entered the remote compatible or the past year. Methodology: in here we show the pictorial view of a SR model. ds by dt denote the rate of changes of susceptible individual over time. Di by dt represent the rate at which the number of infected individuals changes with time, and the differential of R represent the rate of at which the number of recovered individuals changes with time. Here show the breakpoint estimation of a SR model. There is an infection point of graph of the infected people. We found the infected maximum I max. That means at the point where the condition where the growth is stopped, that is di by dt equals 0. Here we simply divide the population into different age group, then formulate the SR model based on the specific age group to see which group is infected number of bigger than the other group. We collect experimental data analysis. We collect a data set from IEEE. We use two types of data set: a web-based data set and the one case-based data set. Web-based data set has 4 features: date, susceptible, infected, and recovered. Our age-based data set 11 features. And we see the web-based dataset, and we see the age-based infected dataset. Then the experiment result analysis. In SR model prediction, we first calculate two parameter value called the infection rate beta and the recovery rate gamma. Comparison of the predicted curve with the actual data point. The figures show the comparison of the predicted curve with the actual data point. Represent the comparison between the predicted curve with the actual or real data point. The red point indicate the actual data point, while the blue line indicate the predictive model value. Here show the comparison table between the real data and predictive model of four waves. The table show that there remains pretty much similarity between the expected breakpoint and the actual breakpoint. Here you see the age-based infected people percentage. Infected, so the infected people estimation based on the most susceptible age group. Then we see the comparison between predicted curve and the actual data point of selected age group. The blue line represent the predicted curve and dot red point represent the actual data. In this figure, compare predictive and actual data for various age range. The blue line represent the predicted data and the red line represent the actual data. Breakpoint estimation result of age-wise table represent the age-wise comparison between the predicted and actual breakpoint. And then we see the comparison between the selected age group and the all age group. The first figure show the comparison between predicted and actual data point with total age group, and the second figure show the comparison between predicted and actual data point for selected age group. Then we show the comparison of the breakpoint estimation, SR model traditional and age-based SR model our proposed. The two classes, total population and selected age group, predicted breakpoint and the actual breakpoint, and we show the difference between predicted and actual. The table show there is a less difference between predicted model and the actual model in the selected age group. So that means selected age group gives a better result than the total population. Conclusion: this research supports the sustainable healthcare and public health by guiding the policymaker and the healthcare professional to optimize the pandemic resources for vulnerable age group and enhance the industry and government for future health service. There is some references. Thank you.